Hello everyone, we are Virtual Engineering and this is Electroverse. We are in the single-phase circuits laboratory. In this video, we're going to teach you how to make a series connection with two resistors and measure the total current of the circuit. Well, the circuit will look like this. Here is our main power supply. We'll have an ammeter and a resistor. Another resistor, and here we'll close the circuit. And here we'll have a voltmeter, and here we'll have another voltmeter. So we can see the voltage drop across each of the resistors. So these will be the circuits that this will be the circuit that we're going to build. So in this situation, we need to have two voltmeters available. I'll walk over to the shelf, carefully grab another voltmeter, unlock it right here, pick it up gently by hand, and then bring it over to the table where we are working. And here I lock it in place. This is one way we can avoid dropping the instrument here in the virtual world. It's better if we always use it locked in place. I'm going to grab another resistor. Put it here on the table, another resistor, and I'll lock it in place. So now I have my two resistors, the ammeter and the two voltmeters. I can already start making my connections. I'm going to grab a shorter wire here and start making my connections. Alright, so here's the first leg of my circuit, and now I'm going to connect the resistors in series. And now, I'll carefully proceed to make the return as planned to the main power supply unit. Done. And now I'm going to connect the two. I'm going to use a white wire and a slightly shorter wire. And now I'll connect the two voltmeters in parallel with the resistors. Alright folks, so the setup is done here. I connected the ammeter in series with the two resistors and the two voltmeters in parallel. And I'm going to calibrate it here. I'm going to set this resistance to approximately 250 ohms, so we can evenly split the voltage and observe that. Alright, so my circuit resistance is 250 plus 250, which is 500. So my current situation at this point in time, this will be equivalent to V over Z. I'm going to apply 100 volts. And when the value is over 500, it cancels out. So as a result, I'll have 0.2 amperes. That's the current I'm expecting. And the voltage will be split in half. So the voltage across this resistor here, specifically 250 times 0.2, will be 50 volts. So I'll have 50 volts on each of the voltmeters. So let's do it. I'm going to set it here to 100 volts. So here I am, 0.2 amperes on my ammeter, just like we calculated. Approximately 50 volts on the first resistor and approximately 50 volts on the second resistor. So we can see that in a series circuit, the total voltage. The applied voltage is divided based on the resistance. That is, if I decrease this resistance, I will decrease the current and I will decrease the voltage across this resistor. See? If I increase the resistance, the voltage across it increases to the point where the voltage can be much higher on it than on the other, and by increasing the resistance, I always decrease the current. Look, here I'm already at 0.14. So I'm going to decrease this resistance a little more here. By decreasing this resistance, I increase the current. However, the voltage across this resistor drops and across the other one increases. Now I'm doing the reverse process. Watch the behavior of the voltmeters. Look, one decreased, the other increased, one decreased, the other increased. So this is how the voltage behaves across the resistors. So that's it, folks. This is the series connection of resistor circuits in a purely resistive circuit.